Hello, everyone. Welcome to Backyard Musings, broadcasting live from Apple Valley, California. I'm Steve, and Scott is not here. He's still sick. He is sick. He and his wife on medications. Um, Hopefully, we'll see him tomorrow, man. Nobody misses Scott more than I do. It's like I feel like I'm floundering out here by myself. Scott is like the color commentary that this channel definitely needs. All right. I promise you a pretty exciting segment today, and I think it is. Transforming carbon dioxide into valuable chemicals presents an exciting strategy for reducing CO2 emissions and mitigating climate change. Not as if we're not climate Nazis over here. We're not. We would like a clean environment, but we're not going to shove anything down your throat. We don't want people to shove it down our throat either. Designing photocatalysts that harness light energy to facilitate CO2 conversion is a key objective in the field of functional materials science. Talk to your teenager about that, see if they want to follow that in college. I never knew that existed when I went to college. I know materials science was environmental science, what functional materials science. Though various types of photocatalysts exist, coordination polymers, which I'm going to refer to as CPs, coordination polymers, are a particularly attractive option. These heterogeneous materials can integrate the functions of light absorption and CO2 reduction catalysts simultaneously. Moreover, CPs can be synthesized from earth-abundant metals and organic molecules, which makes them widely useful at an industrial level. Would you like to know more? In August 2022, Professor Kazuhiko Maeda and colleagues from the Institute of Science, Tokyo, Japan, again, Japan, science and technology, boom, reported a precious metal-free CP called KGF9 that served as a standalone photocatalyst for reducing CO2 to formate. Formate is a solid fuel that can be stored indefinitely and could be used to heat homes or power industries, thus replacing fossil fuels. Like it. Although KGF9 was highly selective, its photocatalytic activity was rather low, as evidenced by its low apparent quantum yield. I'll refer to that as AQY. Now, in a more recent study published in Advanced Functional Materials on November 13th, 2024, Maeda and his team managed to greatly improve KGF9's performance through an alternative synthesis approach, highlighting its previously untapped potential. This is like, for my small pea brain, it's like fuel pellets. You can heat your oven with your wood-burning stove with fuel pellets. It's like sliced bread to me. Anyways, that's my analogy. The approach in question was a microwave-assisted solvothermal method, which involves heating a solution in a sealed vessel using microwaves. Okay? Quote, volumetric heating with microwaves can directly and uniformly heat the entire reaction mixture, causing molecular rotations that result in a drastic increase in the reaction rate, end quote, notes Maeda. On top of speeding up the production of KGF9 from 2 full days to as little as an hour, this synthesis route had other important effects. After thorough testing of the samples produced, the researchers noted that the microwave-assisted method produced thin KGF9 fibrils with a much greater specific surface area and crystallinity than the previous synthesis route. Subsequent photocatalytic experiments revealed that these improvements led to a massive boost in AQI for CO2 to formate conversion. To put this into numbers, the AQI of the newly synthesized KGF9 was 25%, which represents a near tenfold increase compared to the 2.6% value previously reported. Man, would like to see it much higher than that. Quote, this AQ, that crow is he spying on me? This AQI represents a record high value among reported heterogeneous photocatalysts for CO2 to formate conversion, is even on par with AQI reported for homogeneous photocatalysts, remarks Maeda. Okay. The research team then conducted mechanistic studies to understand the origin of observed improvements in CO2 to formate conversion. Through careful analysis, they concluded that producing well-crystallized KGF9, those fibrils, with few surface defects was a decisive factor. Interestingly, by combining KGF9 with a carbonaceous conductor, they found that this compound also proved suitable for the electrolytic reduction of CO2, which uses electricity in an aqueous medium instead of light to drive the conversion of CO2 to formate. That sounds like a battery. Okay. All right. So, what does this kind of all mean? Let's put it together. Until recently, reducing CO2 to formate had problems with low carbon efficiency, or they produce fuels that can be hard to handle, toxic, or flammable. The new, and immediately when you think of that, think of Beaker. Remember Baker from the Muppets. The new process achieves a conversion of well over 90% and eliminates the need for the inefficient heating step by first converting the carbon dioxide into an intermediate form, liquid metal bicarbonate. That liquid metal, that reminds Terminators. The new ones are liquid metal. Huh. The T1000s. All right, let's get back on track, Steve. That liquid is then electrochemically converted into liquid potassium or sodium formate in an electrolyzer that uses low carbon electricity, for example, nuclear, wind, or solar power. The highly concentrated liquid potassium or sodium formate solution produced can then be dried, for example, by solar evaporation, to produce a solid powder that is highly stable and can be stored in ordinary steel tanks for up to years or even decades. Are you catching the ramifications of this? I mean, you could take CO2 from any emission anywhere in the world and turn it into this powder that can be used to create energy, electricity, heat, whatever. I think it's I think it's breathtaking. But if this can be done on a massive scale, like an industrial scale, then it's going to help a lot of people, which I'm all for. And I know, speaking for Scott, I know I'm treading on thin ice here. Speaking for Scott, I think he would like this too. Folks, I hope that we see Scott tomorrow. Nobody hopes more than I do. You guys don't hope as hard as I do. I hope he's here tomorrow, and I hope he's watching and seeing me begging for him right now. Okay, folks, we'll talk at you tomorrow. Have a great day. What? I want to do that.